Hello everyone, welcome back to my channel. This is the fifth video in my All About SDLC software development lifecycle series. In the previous video, we discussed the second stage of the waterfall model, that is analysis and the feasibility study. If you haven't watched that, make sure to check it out first because today's topic is the next logical step after the analysis. Let's begin today's topic, the third stage of the waterfall model, which is the designing phase. Once we are done with the requirement collection and the feasibility study, we move to the designing. This is where the structure and blueprint of the project are created before any coding begins. The designing phase happens in two ways, architectural designing and UI or web designing. In this video, we will discuss only the architectural designing part. Architectural designing is handled by the architect. Handled by the architect. It defines how different components of the software interact with each other, how the servers are connected, how data flows, and how the application is structured internally. That means the designing the architecture of the application or project is called architectural designing. Let's continue with our same example, the Citi Bank Online Banking software. Imagine you open your browser and type www.citibank.com. You want to log in into your online banking account. So you want the login page. So after entering the URL, the login page will appear. The login page will look like this one. This is the picture which I have taken from the Google. Now, let's see what happens step by step. You have entered the URL onto the browser and the login page will open. Onto the login page, what you will see here, one, enter the username, another, enter the password and the login button. Now we will see how step by step procedure will happen to open one login page. Okay, so let's see. Onto the browser, you have entered URL as www.citibank.com/login. After entering to the URL, this type of web page will open. Okay, so how it will open? After entering the URL to the browser, the request will send to the web server. Now we will going to draw a web server. Web server. This is also called as the presentation layer. The request from the browser will go to the web server. The request. Now, why the web server is used? The web server is used to handle the URLs which we have entered onto the browser. And also the web server is used to handle the HTTP protocol request. This is the function of web server. Now, some real-time examples of the web server are Apache, Tomcat. Example are Apache, Tomcat. After handling the URL into the web server, the request will go to the app server. This is the app server. App server is also called as API layer. So, why the app server is used? App server is used to store the developer's code. That means the code for each and every function, such as login, sign up, or to check the balance, that and other functions. After going to the app server, the code of the login page will run, and login page will appear. After opening the login page, the user have to enter their username and the password. So, if the user enter onto the login button, the main thing is that they need to check whether the username entered by the user or the password entered by the user, is it correct? Is they are matching? So, to check that, the third server is used, that is the database server. Database server, or we can say it as DB server. The function of the database server is to store the customer's data. Means in the database server, the customer's data such as username, password, their balance, and other things are stored. The examples of the database server are SQL, MongoDB, Oracle, and others. After the app server, the request will go to the database server. Now, in that database server, it will check whether the username entered by the user or the password entered by the user, is they are correct, is they are matching. It will check into the database server, and if the database and if they are matching, the database server will send response to the app server that they are correct. Sending a response to the app server. App server will going to send response to the web server. Web server will send response to the browser. After that, the home page will open. The examples of the app server are WebLogic, Logic, WebSphere, JBoss. This is the response. Now, let's understand a real-time scenario. Suppose your university has released results online. Okay, and 1 crore students are trying to log in at the same time. Here what happens? The users enter the URL onto the browser. The browser will send 1 crore request to the web server. Now the web server will send that same request to the app server. The application server tries to process them. After some time, because of the overload, the app server may get crashed. So, how do we solve this problem? To solve this problem, we are going to use the load balancer in between the web server and the app server. Here we will going to add. The job of the load balancer is to divide the incoming request among multiple app servers to balance the load. That means instead of one app server handling all 1 crore requests, the load balancer sends them to the multiple servers. Understand, here we have added 3 app servers. App server 1, app server 1, app server 2, and app server 3. Each of these app servers contain the same code, so any request can be handled smoothly. So multiple requests will go to the this one, and third one. Now, as the number of app server increases, we also need more database servers. But here is the difference. App servers contain same code, while database servers store different types of data, such as the database server 1 will store login data. The database server 2 will store the sign up data. The database server 3 will store account balance data. All these databases are interconnected to form a complete system. Means they are the request from app server 1 will go to the database server 1 also, database server 2 also, and database server 3 also. From app server 2, database request will go to the database server 1. App server 2 request database server 2. App server 2 request database server 3, and as follows. And as the requests are coming to each and every database or the app server, the responses will go from each to everyone. Like database server 1 to the app server, from here also, from here also. So let's walk through the complete flow again. You type the login URL in your browser. The web server handle it. The web server handle it and sends the request to the app server. The app server runs the login related code and open the login page. You entered the username and the password. This data is sent to the database server for verification. If your details are correct, the response travels back up through the app server and the web server to the browser and you log in successfully. There are two types of architecture. If the communication happens between one web server, one app server, and then one database server, then it is called as a three-tier architecture. We will going to write here that there are two types of architecture. The first one is three-tier architecture. The communication, if the communication happens between one web server, one app server, and one database server, then this is called as three-tier architecture. Tier architecture is mostly used for applications with fewer users. At that time, the load is not more. So the next one is n-tier architecture. When the communication happens between one web server, multiple app server, and multiple database server, then it is called as an entire architecture. Communication happens between one web server, n app server, and n database servers. Entire architecture is used in large scale applications like banking, e-commerce, or university result systems where there is a high traffic and millions of users. Now the question is, why do we usually have only one web server? In the entire architecture there are n number of app servers, n number of database servers. Why n number of web servers we are not using? Because the web server job is to handle URLs or the protocol request. It doesn't process heavy logic like the app or the database server. So usually one is sufficient. Okay. Next question is like, does every request from the browser will go to the database server? No. Only the request that needs to fetch or store data go to the database. For example, if you have entered your username and password onto the login page, then only your request will go to the database because it has to check that your username entered by the user or the password, if they are correct, only that time the request will go to the database server. But when the pages is like about us and help, at that time the request will not go to the database server. And the third question is like, where when do we use load balancer? When there are multiple app servers and high user traffic, the load balancer is used, and the load balancer helps divide load evenly in different app servers. In short, the architectural design phase defines the structure and communication flow between different servers, ensuring that the software is scalable, reliable, and performance efficiently even when user traffic increases. That's all for today's video. In the next video, we will move to the second type of designing, that is UI or web designing, where we will see how the user interface of the software is designed. If you found this video helpful, please like, share and subscribe to my channel. And also follow my Instagram handle for more updates. Thank you so much for watching, and I will see you in the next video.